Okay, we're back. And here we're going to kick off the second set of packet walk information that we have, right? What we're looking at here is a two-tier or multi-tier topology, meaning that we have so much of the same stuff that we had last time, right? I've got my external system, and that's connected to the physical network, and that physical network is connected to our tier 0 gateway. The tier 0 gateway has a DR and an SR, right? The SR is attached to the uplink, and the DR is where my router link is. And we have a router link interface and segment this time, the T0 T1 transit segment, because that's connected to a tier 1 gateway. Now, the tier 1 gateway here only has a DR, right? There's no service router associated here. It only has a DR. So we have a tier 1 gateway, and that tier 1 gateway has the downlink to the segment where my virtual machine lives. And virtual machine, again, is going to be 10.1.1.10. So this is more or less the same scenario as the last section, but we've added that tier 1 gateway to the mix. So what happens here? Well, here I have the same communication that I want to do. I want to communicate from 10.1.1.10 out to 192.168.10.1. So what are we going to do? We're going to send the packet to our default gateway, right? 10.1.1.10. Now, the default gateway lives in a distributed router on the hypervisor, just like it did before. And that distributed router is going to look at its forwarding table when it receives that packet, and it's going to look and say, oh, well, if I want to get to 192.168.10.anything, I have to go to my default gateway, right? That's going to be the closest match, is the 0 route on the tier 1 distributed router. That 0 route points to 100.64.16.0 address. And we're using that address because my tier 0 to tier 1 transit subnet is always going to be in that 100.64 subnet, right? We're using the carrier grade NAT subnet for that. So that's automatically assigned. You don't have to do anything about that. So we need to forward this packet from the tier 1 distributed router. Had to make sure I get my tiers right here. From the tier 1 distributed router to the tier 0 distributed router, right? The tier 0 distributed router, because it's a DR, also exists on the hypervisor. So what are we going to do? We're going to forward this packet across the tier 0, tier 1 transit logical switch. We're going to forward the packet from tier 1 DR to tier 0 DR. And so that's going to happen right inside the ESXi host here, right at the source hypervisor of this traffic, right? From here, the tier 0 distributed router is going to look at its routing table. And its routing table says, well, to get out to 192.168.anything, I have to go to my 169.254.0.2 address, right? That's my next hop, 169.254.0.2. So that tells me we have to go across the intra-tier transit segment now. So the tier 0 DR, just like in the last scenario, the tier 0 DR is going to put a layer 2 frame out on the logical switch, on the intra-tier transit logical switch. We're going to then find out that the destination MAC address is serviced by the edge tunnel endpoint. So we'll encapsulate and forward that to the edge TEP. The edge TEP will pick up that Geneve packet. We'll strip off all the headers. We'll hand that to the tier 0 service router. From the tier 0 service router, we're going to do the same thing we did last time. We're going to look at our routing table. We're going to see we have that static route that'll get us to 192.168.10.1. So we'll go ahead and forward across the uplink out to the physical router. The physical router will make sure that we can get that packet out to that destination workload. So if we look at what has happened here, the routing packet flow has been the same except for that initial hop from the tier 1 DR to the tier 0 DR. Aside from that, everything has been exactly the same as what we saw in the last video. Now, if we look at what happens when the packet comes back in, the packet gets back to NSX, right? Because 192.168.10.1 replies to 10.1.1.10. The tier 0 service router looks at its routing table. It's going to match a different type of route. Notice when we look at this, we've got a match for 10.1.1.10. We've got a match. The match is flagged T1C, or tier 1 connected, right? So the tier 0 gateway knows that this segment, this destination, is connected to a tier 1 gateway. And so that's where we need to forward it. And so we have our next hop of 100.64.0.1, I believe. Fine print, can't read it. So we've got that next hop determined. We know that we need to move the packet from the tier 0 service router, from the tier 0 gateway, to the tier 1 gateway. And so where are we going to do that? Well, we're going to do that on the edge transport node. On the edge transport node, because the DR for my gateway exists on all of the transport nodes throughout my infrastructure, including my edge transport nodes, including the edge. So the packet moves to the tier 1 distributed router on the edge transport node. And then we can be processed further, right? The tier 1 gateway looks at its forwarding table and says, I am connected. I have a connected interface on the 10.1.1 subnet. All right, I have a connected interface. So what do I need to do? I need to forward that packet out onto that segment. I need to forward it as a layer 2 frame. So I need to put layer 2 headers on, and I forward on to the destination segment, the destination logical switch from the edge node. Because remember, the edge node is an active transport node. All of my logical switches are available on that edge transport node just as well as anything else. So we forward that onto the logical switch, the destination logical switch, which means the virtual switch looks at the destination MAC address, sees that that destination MAC address is serviced by the hypervisor tunnel endpoint. So we encapsulate that frame in a layer 2, or not in a layer 2, in a Geneve packet, forward that Geneve packet across my overlay network, my overlay VLAN, to the destination tunnel endpoint. The destination tunnel endpoint will strip off all the headers. It'll do its thing, leave us with a layer 2 frame from the tier 1 gateway destined to the logical switch. Now, we're not passing the traffic through the tier 1 gateway on the hypervisor, not at all, right? The tunnel endpoint strips the packet out, or strips the frame out, forwards it to the virtual switch. The virtual switch forwards that frame to the virtual machine. So that's going out and coming back in. When we look at it, all we've done is added one small routed hop to the outgoing and to the incoming packet flow, because we've got a multi-tier topology. We literally added a router to the hop, to the path. So adding another routed hop makes an awful lot of sense. So we have that. Now, something else to think about. And if you watched and paid attention during the packet processing, during the packet flow, if you watched what was going on, we did all of the outbound routing that we could on the hypervisor, as close to the source of the traffic as we could, right? The service router doesn't live on the hypervisor. We still had to move to the edge. That's okay, but we moved through the two distributed routers on the hypervisor. When the packet came back into NSX, what did we do? We did all of the routing on the edge. And when the packet had to leave the edge, it was leaving as a Geneve packet, going from one port on a logical switch on one on one transport node to another port on that same logical switch on another transport node. So we just had logical switching by the end of the process. So logical switching and logical routing, the packet flows are very, very intertwined. So it's something to think about. So we talked about our multi-tier routing. We talked about single-tier routing in the previous video. Wow. You can look at all this stuff, right? We showed you the routing tables and the forwarding tables. You can map all of this stuff out. This is not any kind of a secret. You can see all of this. You can watch the bouncing packet as it goes through the infrastructure. It's good stuff. Now, come back for the next video. Take a break. There's a lot of stuff. Come back for the next video, and we'll talk about VRF Lite, and that'll be the last video in logical routing. We're almost there. We'll see you soon.